Hey students, this is the note section 10.3, the equation of a circle. So there's going to be a lot of notes for this section, and there's going to be a lot of different ways the problems are presented. So when I'm telling you the things that you need, you've been taught throughout the semester how to find those things. If I tell you that you need a distance, you know how to find distance. If I tell you you have a diameter and you need a radius, you cut it in half, things like that that you should know. And we're going to apply all sorts of problems to our equation circle. So here in front of you is the actual equation circle. This formula here, I'm going to tell you what the pieces mean. So in a circle, we have a center, and the center is represented by the number that will be here, and the number will be here. And we always put a capital C, and then we put our ordered pair. So it's H and K. And I want you to notice that in the formula, it is opposite of H, so negative H. Over here, when I ask you to write the center, it is the positive value. What this is, whenever you take something out of parentheses, you change the sign when you write it down. Just like if I told you to solve this for x, you would say, oh, x equals 2 and x equals negative 5, because we're removing them from parentheses and we're writing the opposite value. Okay, so that's exactly the same thing that we're doing when we're writing down the center of a circle. It is going to be the opposite. If this is positive, you put negative. If this is negative, you put positive. Okay, the R stands for radius. And so in the equation, it is the radius squared. When I ask you to write the radius, you take the square root of it. It can be a decimal answer. It could be a whole number answer. The easy way to remember, because it can get confusing about which one is squared, the actual formula has something squared, something squared, something squared. So that'll help you kind of keep things straight. Okay, so let's go down here. If I have this formula or this problem here, number 1, and I ask you to tell me the center and the radius, the center is positive 4, positive 3. The radius is 4. Okay. Number 2, if I ask you for the center, now when you see a problem like this, that means there's nothing here. It's a 0. And there's nothing here. It's a 0. So this is centered at 0, 0. And my radius is 2. Okay, number 3, the center is negative 5, negative 3, and my radius is 1 because the square root of 1 is 1. Okay, you tell me the center and the radius for number 4. All right, hopefully you said the center was 5, 1, and that your radius was 5. That is correct. For number 5, the center is negative 2, positive 3, and my radius is 6. And then for number 6, my center is positive 1/2, negative 3/4, and my radius, the square root of 1/4. 4 is a perfect square, 1 is a perfect square, so that means the radius is 1/2. Very simple. Okay, next section is, given the center and radius, write the standard form of the circle. Okay, so I'm going to do number 8 with you. So if I'm going to write the equation, what I recommend is you do this, and then we're going to put the x and the y. Okay, and we're putting the opposite number in here. So this is the opposite. So what we're doing is the formula is minus, and then you put your number, so x minus 3, and then this is y minus a negative 2, which is why it's positive. And then my radius is 2, so we have to square it to be 4. Number 7 is going to be just like number 2. So when the center is 0, 0, it's just x squared, y squared, and then the radius is 1. 1 squared is 1. Now, if you wrote it like that, wouldn't necessarily count it wrong, but simplified, the 0 should not be there. Okay. Would you please give me this equation for number 9? Now, when I am giving you the questions, I'm not going to be able to put squared, so I'm going to say SQD. SQD, so parentheses, And then I'll put SQD so you know I'm talking about the parentheses squared. All right, go ahead and do number 9. Write the equation. All right, there you go. Okay, number 10, x plus 1 squared plus y plus 3 squared, and then my radius is 6. 6 squared is 36. Okay, remember, if this was like the square root of 6, remember you would just put 6. That happens sometimes. Okay, number 11 and 12. Given the coordinates of the center and the radius, write the equation. So my answer is still an equation. No matter what, I need the center and I need the radius. You guys can get that off of the graph. Here, the center is 0, 0. And the radius, you can count 1, 2. My radius is 2. All you need are those two pieces to be able to write the equation. X squared plus y squared equals 4. Okay, and then number 12, my center is -2, +2. So it's just manipulating what you're starting with. You're starting with a picture instead of me giving you this information, and you get this information off of the picture. The radius, by the way, whenever you're counting the radius, you have to count along the grid. So you can go vertical or horizontal to count the radius. And so my radius, no matter which way I count, north, south, east, or west, it is going to be 2. And so my equation would be x, let's see, it was -2, +2, that's right. So x plus 2 squared plus y minus 2 squared equals 4. Very good. All right, then we get into some coordinate geometry. So it says the point 1, 2 is on a circle. So that means on my circle, I have somewhere the point 1, 2. And the center is 5, -1. So the center is 5, -1. Write the standard form equation of the circle. Okay, well, in order to write the equation of a circle, I have to have the center, which I am given, and I have to have a radius. Well, we're going to use the distance formula to find the radius. Would you please find the radius for this circle using the distance formula? All right, you should have got that the radius equals 5. And so then to write the equation of the circle, it's going to be using my center and my radius, x minus 5 squared plus y plus 1 squared equals 25. All right, you should have no trouble with that by now. All right, next question says, the equation of the circle is given to us. Graph the circle. Well, they already gave us the picture of it, but I want to show you how you would graph the circle. So I'm going to draw me another grid right here. If I were to tell you to graph this circle, first thing you would have to tell me is the center. The center is -2, +3. Okay, so -2, +3 is about right here. And then the radius is 3. So that means we have to count north, south, west, east, 3 units, and get those points, and then we kind of draw our circle around it. So if I'm going to go up 3, right 3, down 3, and left 3. And then you just do your best to curve to make the circle, and it does not have to be perfect. Okay, that's how we draw a circle. And so if you were to describe how to draw this circle, our center would be 3, 4. My radius would be 3. Let's just go ahead and sketch a graph of it. 3, 4. And I'm going to go up 3, down 3, left 3, right 3. And then we're going to attempt to somehow draw a circle in that. Okay? All right, we're almost done. So the next thing that shows up in these problems is taking a circle equation that is not in standard form and writing it in standard form. The equation that you're looking at right now is a circle. But can you tell it's a circle? Can you tell me the center? Can you tell me the radius? No. So that's why the other form of the circle is much easier and nicer to have. And so what we do is we use what's called completing the square to put the this equation into the correct equation. Now, it does follow some steps that you need to follow, so make sure that you are showing your work when you do these problems. First of all, you do need a formula. B over 2 squared, okay? B over 2 squared. So, and we're going to just bring back some algebra for you to kind of review. First of all, what is this B thing? Well, we have a quadratic. Okay, we have a quadratic, A, B, and C. Just like when you were doing the quadratic formula in Algebra 1, the number in front of x squared is your A, the number in front of x is your B. That is what we're looking for to get this number here. All right, so let me go over the steps to complete the square. All right, first of all, is we group the letters together that go together. In this problem, the x's go together, the y's go together, this 12 is all by itself. Down here, we're going to group these together, and the 8 is by itself. Okay, so first thing we do is we group it together, and we leave a space. Okay, so watch what I do. I'm going to put the x squared minus 8x, and I'm going to leave a finger space, okay, because something's going to go there. And I'm going to put plus y squared minus 8y, and I'm going to leave a space, and I'm going to put equals. Whatever this number is that doesn't have a variable, it is going to be added or subtracted to the other side of the equals. So that means I now have a positive 12 over here. All right, this empty space is going to be filled using this formula. This formula is what we call the constant to complete the square. Now, when I'm talking about completing the square, what I'm making is a perfect square trinomial. A perfect square trinomial, let's see if I can come up with one. A perfect square trinomial factors into those two parentheses, but the parentheses are exactly the same. You can do the x factor, although you won't need to because this is super easy. All you do is you ask yourself, what times what gives you 25? And then you put your signs in to make this work. If this is a positive, both of them are negative. If this is it has to be a positive. So whatever the sign is here is going to go in these two spots. So a perfect square trinomial creates a binomial squared, which means I have two of these. And that's what we have to have in our formula because our formula looked like this. Okay, so this was just an example of what a perfect square trinomial looks like. Okay, so the way we get this is your B. You are always going to be adding it. Okay, so even if I put a negative 8 here, negative 8 divided by 2 is negative 4. Negative 4 squared is a positive 16. You could leave off the negative because you're going to be adding it no matter what. Okay, or you can put the negative into the formula if you want. So because this is an 8, it's going to be the same thing. Now, in an equation, I have an equation that has an equals, and I just added a 16 over here and a 16 over here. My equation is not balanced, so whatever you add to the left, you have to add to the right. Whatever you add to the left, you have to add to the right. Now, this guy right here is going to factor into that. This is how you get it. What times what gives you x squared? X times x. What times what gives you 16? 4 times 4. This guy right here, his only job is to tell you to use that sign. He's the sign holder. And so you put the negative in there. Put your plus. We're going to do the same thing for this. Y times y. 4 times 4. He's saying, hey, you got to use a negative. And then 16 plus 16 is 32, 42, 43, 44. Okay. So we are going to, we're actually done with the problem, but the way we always end this is we tell the center. My center is going to be positive 4, and my radius is the square root of 44. Depending on what your worksheet tells you, we can give, typically when we're saying what is the radius of a circle, we can say that it's like 2.3 centimeters, but we can have radicals as the radius. So I'm going to go ahead and give you decimal answer and radical answer depending on what your worksheet says. So this is 4 times 11, which is 2 square root of 11. Okay, that's your radius. And then if you just take the square root of 44, .63. Okay. All right, number 2. First thing we're going to do is we're going to group our terms together that are alike. X squared minus the 6x go together. Put a finger here. Put plus y squared minus 4y. Put your finger here. Move the negative 8 over to the other side. All right, we're going to use our formula to fill in the spot. You should be able to do this in your head. What is 6 divided by 2? 3. 3 squared is 9. Add it to the left. All right, let's get this number here. So we're going to take 4. 4 divided by 2 is 2. 2 squared is 4. Oh, I got to add the 9 over here. Add 4. Add 4. So remember, we're using this formula to fill in the empty spaces here. Add it to the left, add it to the right. So now this is a perfect square trinomial. How do I know it's a perfect square trinomial? Because that formula, b over 2 squared, is the formula that makes a trinomial a perfect square. So this is going to be x minus 3 squared plus y minus 2 squared equals, let's go over how I got these. X times x, 3 times 3, 6 says, hey, you got to use a negative. Y times y, 2 times 2, this guy says, hey, you've got to use a negative. And then 9, 10, 11, 12, 13, 21. Okay. So then my center is 3, 2. And my radius is the square root of 21, or that decimal, is 4.58. All right, let's look at number 3. Now, number 3 is going to really test your algebra skills. It's going to be a little bit more difficult. We cannot factor a perfect square trinomial unless there's a 1 here. Okay, so it's not going to happen. So we have to do some work. All right, first of all, let's get our spaces and move the 5 over and all that good stuff. Okay, so I've got 4x squared. Because there's no other x's here, this is going to be one of those that looks like this. Okay, eventually it will have just the x squared. We do have the 4y squared, the 36y. And we're going to go ahead and leave a space, and we're going to move that negative 5 over to the right. Now, what do you notice about all 3 of these numbers? They are divisible by 4. Still leave your space. Okay, so what I've done is I factored out a greatest common factor of a 4. All right, so this is one of the issues with this problem. The other issue with this problem is this guy right here is not divisible by 2, so we're going to have to deal with a fraction. So I'm going to come over here and do some scratch work. So my b over 2 squared formula. b is 9 over 2 squared. 9 squared is 81. 2 squared is 4. Be sure you square the top and you square the bottom. Okay, so I put my b over 2 and I squared it and I get 81 over 4. Now I'm going to put an 81 over 4 right here. this is the thing. Because there's a 4 out here, I am not really adding 81 over 4. What I am really adding is that. Whatever I put here multiplied by 4 is what I have added to the left. I have added 4 81 over 4s because there's a 4 out here in front of this parentheses, which is kind of nice. And so what I'm going to add to the right is just 81. Okay, go over that again. 9 divided by 2 does not divide out, so we have to write it as a fraction, and then we have to square it. 9 squared is 81, 2 squared is 4. When I put the 81 over 4 right here, I'm not really adding an 81 over 4. I am adding 4 times 81 over 4. So I write it over here, and I can simplify those 4s. Whatever you get is what you add to the right. Okay, so I still have this 4. This is a perfect square trinomial. It's going to be y. I'm going to use the positive, and then all I'm doing is I'm taking the square roots, 9 over 2 squared. I'm going to close this parentheses because it's that parentheses. And then 81 minus 5 is 76. This problem is just ugly all over, okay? I can then divide 76. Let's see. Divide 76 by 4. So I'm going to divide by 4. And I have this equation. And now this equation looks like the standard form of an equation. And now I can tell that the center is 0, negative 9 halves. And I know the radius is the square root of 19. Because remember, this is r squared, so that would be regular 19. And the square root of 19 is 4.36. All right, so if that happens, I'll help you with it if you need help. But I have shown you all the steps. I've shown you how to factor out the greatest common factor. If it left a number here, you have to still factor out the numbers to where there's whole numbers here, okay? And then dividing this number at the end, you have to get your equation looking like this before you can tell the center and radius. All right, that is all the notes. Good luck.